Good evening all, welcome to a new stream. How are you all doing tonight? And more importantly, because I am famished, what are you drinking tonight? Tonight I have some two contenders, a Fanta Zero Sugar in the Shokata lemon elderflower flavor, ooh, and a Sprite Zero Sugar Mint lemon lime taste. What? Mint? Never had that one before. Courtesy both of a good friend of mine. But I'm going to start with the Fanta Zero Sugar Shokata Lemon Elderflower one. I've actually had these before, and they're nice. So, 2 times ultra. No ultra. No need for ultras today. Let's see. Let's lower the music a bit. There. And I'm gonna crack this drink over because I'm thirsty. Your electricity provider dropped energy 10 minutes ago. When new Quinergy will release? I've actually been working on that, maybe revising some of my plans and how the new house will work. I guess we can talk about that at some point. But yeah, those are going to come up in the next year when stuff is actually going to be built. So yeah, let's see. Jacco Wies was here first. Looking forward to this type of stream. I am wondering if I will be able to understand, but interested for sure. Well, we'll see. I hope so. Let me see. Damn, if someone beat me first to the first comment, says Greg, I won't have a clue what's going on, and hope Quindor is talking about it when he explains what the components are instead of just saying it's a chip. And so, what's non-circuit board people? No, we'll go through it in real time and selecting the components and then using them and stuff like that. Really looking forward to this stream, seeing Quinn work in KiCad in real time. Yeah, I'm wondering how long all of this is going to take. It's certainly not going to be beneficial in the speed effectiveness of this project, but I wanted to give it a try, and you know, maybe you like it, you guys like it, maybe I like it, we both like it, and we'll do more in the future. We'll see. Foxionaire is here, really looking forward to this. Oh, you said the real-time stuff. And Medved, hoping for an Eli 5 version of this stream. Good evening all, says Greg. And Kvik DK is here. Kavala and Draadstal announced the music. I'm going to take a drink. Boss ZT and one patient says beer. Well, cheers. Oh, Kavala is drinking Fanta Lychee. Not good. Okay. I think I caught up. Okay, Rivella Peach. Oh. No zero Coke sugar. No zero Coke today. I already had a Coke today, so no Coke for me right now. Good holy smoked evening, says Slyzard. Okay. I just installed KiCad for my own project. Installed 10 minutes ago, says Tristan Russello. Okay, cool. Foxionaire says 5-hour stream. I don't know about that. We'll see. We'll see. Greg says, can you all do me a favor and raise a glass to Quindor? I want to thank him for helping me with learning and getting my house done. And my son with learning difficulties loves it. Means a lot. Oh, thanks, man. It's your favorite Fanta flavor. Sadly not available in the UK. Drank it a lot in Germany. Oh, okay. Magic Smoke. Well, if maybe from the computer, like doing PCB stuff. So we've got to prepare, actually. I didn't prepare well enough. Let's see if this screen works. Yeah. Okay. Let me kill that real quick. So let's first go to KiCad.org. So I need to figure out what I'm going to do, because this way the screen doesn't really fill up. So maybe I need to do this in... Okay, I'm going to move the OBS window to my other screen. Let's see if the stream crashes. I don't think it did. And then I'm going to take this window. I'm going to move it to this screen and make it full screen. Oh. Okay, now it's too big. Where's my OBS? It's still too big. Okay, so this window needs to be less tall. But I want it to be wider. So like that. No, okay, we can make it bigger. Ah. Sure, that works, I think. I can't really see the preview anymore because now my preview window is so small. Let me open a preview on... Yeah, okay. Yeah, that's fine. That's good. Okay, so let's keep it like that. And so let's see if I have the newest version of KiCad. Now, I know KiCad 10 is out. Or they're even working on KiCad 10 release candidate, or 10.0.2. But I'm still on 9. I think we'll stay on 9 for now. I don't really want to learn new KiCad on the stream. So we're going to go to download, Windows, and we're going to go previous version, and I want the newest 9. Full build, x68 for, yeah. Okay, I don't know if I already had that version on this PC. Yeah, the only smoke will be from Quindo's brain when we drive him crazy with suggestions. Probably. Today, I want to maybe figure out the physical dimensions, but at least figure out the connector that's on the back here. And find that. And then we can put the pins that the connector has on there. It's kind of a first building step. And then maybe finding some of the components on LCSC. That's what I generally use to find stuff. So, let's see. 9.09 downloaded. I don't know where it's going to pop up. Okay, well, the install is just next finish. So don't worry about that. Hey, good. Yeah, maybe to do 10. Yeah, I guess that's also true. Do we want to figure out KiCad 10 together? I don't know. I guess I could install 10. I'm not sure I can transfer existing schematics I have to 10, though. Well, I guess then I have to recreate them, huh? Normally I spend so much time. I can spend days, and then I mean 12 hours a day, and then multiple days on just schematics. Okay, let's install 10. Did 10 come out today? Looks like it. Because this was a release candidate for 10.02. Okay, let's do that. Let's get 10.02. Don't expect much help. Thanks there, Medvet. No, I'll figure it out. Don't worry. And maybe I can still copy-paste between both versions. I don't know. We'll see. Okay, 10 is downloaded. 922 megabytes. Don't do it, says Arc. Why not? No. Okay, let's install 10. Can I change the browser edge to the installer? Let's see. No, it doesn't show up. Display capture. This one. You still don't see it. What? Where is it? Oh, here. Okay. Fine. Let's do that. I mean, the install procedure is really simple. Okay, it's giving me a pop-up. Yeah, next. 10, next. So, I mean, it's not hard installing it. Yeah, 10.00. Yeah, this is 10.02. That already gives me a better feeling about that they might have fixed some critical bugs, right? And maybe it has more footprints and 3D files and... Yeah, no, I know. But since I depend on it a lot for work stuff, I generally don't upgrade immediately. $10.02. Okay, launch. KiCad is starting for the first time. You can't really see that, can you? No, I want this one. No, I want... Okay, I didn't want that one. I want this one. There. KiCad starting for the first time. Some of the configuration files are missing. Okay, this is new. Import. No, okay, well, we'll start with default settings. That's fine. Built-in libraries. Okay, good. Check updates. You can anonymous data collect. That's fine. Okay. Loading footprint libraries. Oh, it went south very quickly. Oh, okay. Oh, right. I'm here. I'll make the screen go better quickly. Hold on. So I want... Okay, so we don't want this capture. But we do want the browser because we're going to need that. So let's see. Application capture? Game capture, no. Image display. What? Browser? No. I don't understand. I'm already having trouble reading. No, I have a bit of a headache, but we'll manage. So this is KiCad main, I guess we'll call it. Okay. Select window to capture. There. Capture method should be Windows 10. Match title. Sure. Okay. So yeah, this is the main KiCad window. And we have a schematics editor, a symbol editor, might need that, PCB editor, footprint editor, and then all kinds of other stuff. Today we're going to focus mostly on starting the schematics. Like, for instance, I'm starting to become a real streamer here. We have this box here, but we're interested in this connector, and this connector will mate with our PCB, basically the same they did it in this guy, although it's not open anymore. Let me see if I can open this real quick. I think so. I need to break out more tabs, I guess. I don't know. Okay. Right, so as you can see here, these are the same as these. Sure, Greg. That's a different topic, though. So yeah, we need to figure out what connector this is, and then what connector we need on this side. And I want to figure out the pinout for this one, so we have that in our schematics editor and can build off of that, right? So we know which pins we can use, which we can't use, and which functions which have. And well, that's going to be the start of the schematic. So not for this one, although this is the Ethernet one. I want to use this one, and we'll make custom 3D printed plates or whatever, or PCBs. Actually, we could just make all of it out of PCBs. So where they used a little plate here, that could actually be a PCB with cutouts, which then our other PCBs would mount into or use a cable or something like that, right? So we need to figure out what connector that is, because, well, we want to use the same connector. So let me check. I think I need to go here. Yes. And we have our PCB editor, and then we're going to go to create or open a project. Okay, new project. Oh, what the hell is... I've never done this. I always just copy stuff. Default KiCad project. Sounds good. Let's put it on the desktop for now and say this is for the wall sensor. You can't see this. Sorry. Wall sensor panel on stream. Okay. Wall sensor panel. Okay, so now we have a new project called Wall Sensor Power and Panel, and it makes a PCB file and a schematics file. We're going to open the schematics file, and then I need to capture a new window. So I'm going to say capture window, KiCad schematics. I actually have a Stream Deck somewhere. I never understood what I should use it for. Maybe I'm starting to understand. Okay, so let's say this and that. Okay. Now we need to change the size so you guys can see it. Okay, it's too wide here. Okay, and if I now minimize it, does it go away? Yes, it does. Okay, so I can keep all of those captures open. So here, for instance, we have LCSC, where we, look up a lot of components, and then I can just open the schematics editor again, and then you guys also see the schematics editor. Nice. Oh, you're working on an ESP32 Home Assistant and Raspberry Pi 5, same deal. Home Assistant and peripherals using various connectable devices. So complicated. Need the knowledge of Quinn. Well, we'll see about that. It's my first time building one too. Oh, Dutch Maker is here. Good evening, or good morning. No, good night for you. I guess good morning, almost. What is the? Yeah. It's morning. It's morning for you, or late night, something like that. Okay, right. So, this all looks correct, I think. First off, we're gonna remove this bar because I don't need it and it's annoying. Go away. There. We have our PCB thingy. I don't know if you can see well enough in regards to scaling. Let me preview this on my screen here. Open preview projector. Oh yeah, that's fine. Yeah, you can see everything and read everything. Cool. Okay. So, first we have this connector, and it's actually two connectors. You can't see that. It's actually two connectors that are butted up together. We don't care about this one. We only care about this one. So I got out some calipers. Ow. So let's first figure out how many pins we have in what size of space, right? I need something to point with. Okay, that will do. So we have 1, 2, 3, 4, 5, 6, 7 pins on this one. 1, 2, 3, 4, 5, 6, 7 pins on this one, and then times 2. So we have 14 pins here and 14 pins here. But from my eye, this is telling me this is not the same pin spacing as 2.54, which we use a lot, right? Because this is 8 or this is 9 pins, I believe, but that doesn't align. So I think it's 2mm pitch. But in theory, we should be able to tell with this guy. So if we do a 2mm pitch, Let's get this to 2 millimeter. Oh, sorry. No. Why is it blinking? Stop blinking. Okay. Yeah, I'd say that is about 2 millimeters. Why is it blinking? I have a really fancy one, a caliper, but I don't know where I put it. So we're using this one. Battery empty. Yeah, probably. Yeah, so okay, we have a 2 millimeter pitch, and these aren't very high. Let's unscrew it real quick to take a look at the PCB. Yeah, because we're going to need some kind of plate like this. But we could maybe make it from PCB material or 3D printed or something like that. Because this has to screw in there, and then we need to screw our other board or whatever we're going to use that's going to plug in there to this guy. But that's something for later to worry about. Okay, so they're using a SMD style 2 millimeter pitch 2x7 pin header, right? And well, we need to copy that on our board. So we need to copy, this is the female version, so we need the male version of that. Electric screwdrivers back. Yes, I charged them all this week. So let's go to LCSC. Nope, wrong screen. There. And let's try and find that. So we need a pin header. Generally, I just... Oh, there we go. Specialty pins. I was going to say, generally, I just select an item. Let's see. Board in, direct wire to board. Board headers, pluggers. Okay, I think we need this one. Let's see. Why don't I get a pop-up? That's odd. Oh, maybe I need to log in. Oh, wait. Hold on. Sorry. Don't want to show you all the secrets. Where is it? This one? Yeah. I am not a robot. I'm certain of it. Still no pop-up. Okay. Okay. There. I'm logged in so I can add stuff to my cart. So we want SMD 2 millimeter pitch, right? So like that. And then we want... Oh, they've got 2 by 10? Oh. Number of pins. We want 2 rows of 7 pins. Why doesn't exist? Oh my god, it's starting already. Let's see what we find with this, if we're on the right track. Normally okay, I need stuff that's in stock. Normally you get a preview. Yeah, that looks correct. Although these pins are way too long. Now, sometimes you need to kind of figure out what they want to know. Maybe selecting this one is wrong. Let's select the pitch 2 millimeter here. And then let's go for 2 times 7 pin. See, now we can do 2 times 7. No, that's not what we're looking for either. Okay, maybe we're in the wrong section. Let me check. If I want a 1 times 4 pin. Yeah, okay, we're in the wrong section. So regular connectors. Do we need to go here? Maybe. No. See, normally I just look up an item I've used before. No, Dutch Maker, we're on the journey. We're on the journey. So we need to find the right section first. Terminal blocks. Okay, I'm just gonna search for stuff I know. Why is it coming up with other stuff than I'm used to? Normally it gives me just items. Headers, mail pins, no. Yeah, I guess headers. Let's see. Okay, well, immediately it's not working. Yeah, I know it's 2 times 7. No worries. You can't help him if you want a 10-hour stream. That's true. I always struggle where sometimes they change the website where everything is basically put into categories. I just want a pin header. Nope, not today. Oh, there we go. Sorry. I'm just in the wrong section. Okay, we don't want to search. Okay. So, we want number of pins. No, yeah. Pin structure. We want 2 times 7. 2 times... No, that's 3 times. Oh. There. We want it to be in stock. We want it to be 2 rows, but I guess that doesn't really matter. Let's see. We wanted surface mount and vertical. Now let's see what we're getting. Yeah, that looks better. Something like that. Dual row. Yeah. So does that look like what they used in here? Right? The one they used in here has a black border. So probably this one is raised. I guess we need to look inside. Because we do want to match it mostly. Let's see, before I poke this in my fingers. Yeah, the headers they have a little black spacer here, but that might be because they're through hole and not SMD. So I guess we can take this one out too. Oh, okay. Let's see, maybe I need to take these out. Is there more? Oh, there's one more screw. Yeah, I've worked on the Chinese version too, but we should be able to figure it out. Yeah, okay, so the pin headers, the pin headers are here. So the version they are using is through hole. I'm not quite sure why. They also have components. No, they don't have components on both sides. They only have it on one side. Yeah, okay, sure. We could use through hole, or we could use SMD. It doesn't have to be mechanically very strong, because the connection, I mean, they mate, but it's not going to have any weight on there or something like that. So let's see what other options we have here. So like this guy that looks correct. Let's see how long these pins are. Oh, okay, I'll check it. 0. So these are, yeah, that's a bit hard to figure out like this. Oh, wait, sorry. We're blinking already. I don't, yeah, we're pretty sure on the 2mm, but I don't know the length, and I can't really reach far enough. So let's try a different method. There. Okay, so these are about 4mm, I'd say, if the camera does want to cooperate. There. So it's not quite half. Yeah, 4mm long. Okay, let's try and find something that's... Oh, that's true. I could use the depth meter. Okay, well, good point. Right, so these are 4mm. Okay. Oh, wait, these are 1.27. Okay, let's not do that. That's wrong. I didn't put that in yet. Yeah. 2mm. Something like this. .5 amp should be enough. About 3.8mm. Oh, that's the length of the pin, probably. Yeah, these are 3.8. Okay, that should be fine. Let's see if we can also set that. Length of mating pin, 4. Let's set it to 4. Oh, we only get 5 results. Okay. Do we get a lot more of 3.8? Not a lot more. Some more. Okay. Do we get some that are more in stock? No. Okay. So we'll stick to the 4mm. Something like this. Oh. Yeah, that could work fine. Okay. Yeah, 4mm, 14 pins, 2 times 7. Cool. So we're gonna okay, normally for stuff that is more complicated, you want to import footprints and stuff like that. In this case, we can go to our schematic editor, and on the right here, we can say new item. And we're going to search for 2 times 07, I think. Yeah. And you can change the order and stuff like that, but since it's just pin headers, it shouldn't really matter. We don't have a mounting pin, so let's do it like that. And well, I'm just gonna mirror how it's on the PCB. That's just for my own logic. Pop-ups are not captured. Ah, okay. I'll try and fix that. Okay, let's do it again, and see if we can capture the pop-up. Window capture, KiCad, schematic pop-up. Yeah, okay, good. I can actually make it bigger for you guys than I see it. So yeah, this is what I was talking about. You can I just typed in 2 times 07, and and then you see the various schematic symbols. I like this one best. Normally you have to pay attention to these pins, but in the end, for this type of connector, it doesn't matter. So we're just going to do the odd even because I like that best. And yeah. Oh. So they always come with these names. In this case, I don't really care, so I just hit delete on them. This could be interesting sometimes, so I'm just going to put those here. There. Okay. I'm a neurotic saver, so you'll see me hitting the save button a gazillion times and then a few times more, even if nothing changed. We're using KiCad 10. So, if you see me, it does autosave. I believe it actually autosaves each change you do. But I don't trust it. I think this is from the DOS days. Yeah. So why 2 times 7 and not 2 times 14? I'm just mirroring what I see on the boards that Waveshare made. So over here, they also have 2 separate sockets of 2 times 7 and not one of 2 times 14. So I'm just going to mirror that. OCD on steroids. Well, no. Well, it used to be that we didn't have a save feature, and then your work would just get lost, or saved like every 5 or 10 minutes or something annoying like that. So I'm just gonna save every time. Okay. So what we need to do now is go to the Waveshare to the Waveshare website. Okay, I need to minimize KiCad. Yes. And there, all the way on the bottom, they have a wiki link, I think. No. Is this already the wiki link? No. This one? On the backboard, they have more than 2 times 7 on the Ethernet board. Preference, right? I don't understand what you mean. So I need to have a description of each of the pins. And I know they have a schematic. Yeah. So we're going to use this one. And over here. I can't zoom in more. Okay. They have a description of all the pins that are being used for P3 and P2. Now, I need to think. Because the baseboards are basically different, or at least... No, they're not different. Okay, we need to take this one out also. So this is the one officially with the Ethernet. But then we can determine which connector is what. Later, Dutch Maker. Come on. It doesn't want to come out. Okay. More stuff on my desk. Good. So if we take both of them, they're basically the same board, as far as I can tell, except this one has the display connector or the camera connector, this one doesn't. And this one has the 2 connectors, and this one only has 1. That's why I also want to use the not Ethernet version, because then I get both connectors. Will it be so long stream? I don't know. We'll keep going until I'm tired. But basically both boards are the same, but the non-Ethernet version is cheaper and we get more connections. So we're going to use this one and not this one. But I wanted to know what was on their schematic. They talk about P2, which has the Ethernet signal on there, and P3, which doesn't. So if we look over here, this is the Ethernet version. So that has to be P2. And then this is P3. So, okay, good. Oh, interesting. The name of the PCB is the same on both. Oh, you're still at your office, damn. Okay, good. So, physically, at least, we know that this is P2 and this is P3. That's basically what I wanted to know. So if we look at the schematic here, we have Ethernet TXP, Ethernet TXN, and RXP and RXN and stuff like that. And what I want to do, at least for today, is take over these connectors so we have all of these symbols and stuff in our schematic, and then we can start building from there. What we're going to do first, though, is we're going to go back to the browser, because we selected this connector, but we didn't really do anything with that. And what I often do is I go to the schematic, and I hit E for edit. Then I make a new field, and I call that field LCSC, and I just paste the LCSC number in there so that I know which component is selected for, which physical component matches with my schematic symbol, basically, right? And later we'll also have to match this with a physical footprint, but that comes later down the road. Discord down. I don't know. Let me open Discord. No. Oh, yes. I can click on the channels, but the channels aren't loading. Oh, now it did. Messages failed to load. Yeah, looks broken. Messages failed to... Yeah, I think Discord's broken. Okay. So if we want to match the schematics, wait, move, I believe the way they have it in the schematics is like this. 1 to 14, 1 to 14. Yeah, 1 to 14, 1 to 14. Oh, if I switch to the browser while it's still up, you don't see that. Okay. So we now have, I guess we could call this P2. And this is P3. From the WaveShare schematics, right? Okay. Yeah. So if we look here, we're just going to copy all of these. Well, that's interesting. They have VCC 5 volt on 2 of them. Okay, we'll have to figure that out. Right, so we'll start with the left one, ESP, and we're just going to copy their naming, because then we kind of know what it's connected to. Now, I'm not going to do conventional methods. I'm going to use the methods I use, and I like using... oh god, it's a new version. How does this work? Do I need this one? No. I don't like using net labels. I use them sometimes, but... poor internet tutorials, Greg. Something like that. I don't know. I want a global label. There. Also no. What? How do I do this in this version? Called ESP32 schematic. And this is called ESP I2C. Wait, they're both called ESP I2C? How does that work? Oh, what? I am dropping frames like mad. Why? Hold on, hold on. Let me check. No, my CPU is fine. Yeah, I've dropped. Let me do a speed test. Okay, my download. No, my GPU is fine. I mean, later one patient. Yeah, so my internet is fine. So maybe Google is having issues? No, so I can see in my OBS the frames missed for rendering lag and the frame missed out of 100,000, so that's 0.0%. And then I have dropped frames for the network, and that is dropping frames. So YouTube is having issues. I could try switching to the... Are we back? So far I have 0 dropped frames to the backup server. Working again. Yes. Yes. This is better. Okay. Okay, good. So we'll continue on the backup server and we'll see how that goes. I don't know. No, YouTube. I only changed the footage ingest server on the YouTube side. They have a primary and a backup one. So I switched to the backup one now, and now I'm not seeing any drop frames. It's still cutting out. Maybe try refreshing your browser, Soul Juice. For safety, I would recommend KiCad 9. Anyway, if we go back to the schematics of WaveShare, we immediately encounter an issue. Because it says ESP I2C. Okay, sure. But why is there 2? As in... Normally you have an SDA and an SCL. You don't have 2 I2Cs. That doesn't make sense. So let's see where these go. Ah, they do have 2. Okay. Okay. Sure. It's linked to a lot of stuff. Okay. So we can't know which one is which. Oh, their schematics are borked. Let me try something. Nope. If I copy paste it, I also can't find it. Oh, maybe if I copy paste this. Yes. Okay. Now it says SDA. So let me copy that. And here I'll just duplicate it. There. SDA. Okay. SCL. Well, the ESP32P4 can do multiple I2C buses, so I don't think we'll use the one that also has a lot of other devices already connected on the main board little thing itself. We can just do 2 I2C buses, but we'll see about that later. But that's my plan for now. So we have GPIO 2, 3, 4, and 5. Okay, so I'm just going to copy this GPIO 2, 3, 4, 5. Okay, and on the other side, we have VCC 5 volt, as they call it, which then goes through a diode. But that's on their board side. Okay, yeah. Oh, wait, we have to think about how this is mirrored. Okay, we'll have to figure that out later. No, don't want to do that. So VCC 5 volt, and then we have ground. Okay, we're going to use a ground symbol for that. Does this now pop up? Yes. And we're going to use a power symbol. So we're going to call this ground, and we're going to put that, I don't know, somewhere over here, and then we'll link that to there. And then let's see what we have. We have GPIO 37, 38, 20, 21, and 22. Okay, so this is... Oh, wait. No, come back. So we're going to do this. Now, I already forgot the numbers. 37, 38. 37, 38, and 20, 21, 22. 20, 21, no, wrong, 21, 22. Okay, yeah, I'm hitting save, don't worry. And then on the second connector, we have ETH TXP positive, okay. I believe we also have then the N, and then we have both of these, the RXP and the RXN. Yeah, and then we have USB in 1P. Oh, not quite sure what that does, because the USB ports are all on the other board, on the board that's already in there. So okay, that's just N and then ground. And then this one also goes to ground, like that. And let's see, we have VCC 5 volt, same as on the other one. I don't know why they have two. I'm not sure that's going to work great. So let me add a... Okay, I always add notes for myself. There. We'll have to figure that out later. And then we have ESP32 3v3. Oh, we also have already that one. I guess that's they have those double because they sometimes have the the one board doesn't have the other connector, right? So that's probably why they did that. This board doesn't have this connector, so that's why they have the same power on the other connector also. Might have done that differently, but okay, sure, that's what it is now. Let's see then. We have GPIO 32, and they are connected to something for them. Oh, TX and RX might be interesting. Okay, we'll copy that. Oh, damn it. So this is GPIO 32. And then we have 46. And then we have 47 and 48, which is also TXD and RXD. Okay. 47, 48. Okay. $47, $48. This is another ground. And we said that this is TX and RX. Okay. So I'm just gonna do something I sometimes do. Generally, it's supposed to do it differently, but this is the way I do it. It's not the official way to do it. There. Okay. This one also twice. So we need to think about if we indeed want to connect that twice, or if we don't, and we only connect one of them, right? Because we have these double, and these double, and although I guess you could hook it up that way, I don't know what that will do for EMI and such. So okay, the YouTube still seems stable. Okay, now would be a good time for an advertisement. No, just no. Electromagnetic interference. Yeah, if we want to do like CE testing or FCC or whatever, you know, we need to take that into account a little bit. Now, here comes an interesting fact. This is the schematic of this board, right? Of this guy. So, the bottom board, are they going to be mirrored? Probably, because if we look at this guy, oh wait, they did it like this. Right, that's probably why they used a through hole, because they have all kinds of stuff on here. Right, they have all kinds of stuff on here, and then they have the connector on the back. That is actually probably the way to go. And it might be cheaper to make that a through hole than an SMD part, because otherwise you have to SMD reflow on two sides, and now you can just pay them to solder those pins. So having the connector on this side, so the pins would stick out on this side, that wouldn't be practical, because we're also going to have like a socket like that, and maybe some other components that are going to be higher than the actual socket or connector, right? So we might have to mirror this. And then, if we design it like this, the pins aren't mirrored because well, yeah, okay, maybe they are. What? Yeah, I think we should also do a through-hole connector, and not the SMD one we now selected, because they probably figured that out already. Okay. So we go back to LCSC. And we're going to change this to... Oh, it only has SMD? Did I... Oh, yeah, okay. We don't want surface mount vertical. We want through hole. Okay. Well, yes, this is the thing. This is the thing that takes up the most time. Everybody also always wants to start laying out stuff on a PCB. That is the very last step. Okay. Let's see. These are like a few cents. That's fine. We got a lot of these. Let's see. 2 millimeters. Double row. 4 millimeters mating. It has the spacer. Yeah. All good. Okay. So we're going to copy the LCSC part number. And we're just going to replace those in here. No. Why are you small again? There. Yeah, you can see that. Okay. Wait, did it do it? No? Wait, that's wrong. Copy. Edit. Paste. Okay. Well, yeah, this is part of it. Many more hours to go, Greg. Many more hours to go. Okay, so now we at least know what all the pins on the connector are. And now we can start connecting stuff to those pins, right? And that's going to be a whole different ball game. Because we need to figure out what we want to connect to those pins. How to best proceed forward. So I believe in our notepad document, let me see if I can pull that up. Yes. No, it's gone. What do you mean? Yeah, here it is. Okay. Yeah, we determined that I'm gonna add another overlay because, you know, notepad document. Okay. In this one, we determined that what the custom waveshare board needed to do. So the custom backboard, and then after that, we're also going to have a custom sensor board, but that's going to be connected with a ribbon cable or something like that. No, start with the easy one, the Ethernet. No, that's going to be the hard one, I think, there, Philip. So we want 100 megabit Ethernet with PoE input, and then PoE power source for everything. So that needs to provide the 3.3 volt, 5 volt that goes to the to the main board here, where it's the screen and the ESP and everything runs off of. But this board makes the 3.3 volt for all of the components on here. So we don't need to make that, but I do want to make 3.3 volt for other stuff we're going to be running and connecting. But okay. Does all the power conversion, yeah, 5 volt board to the ribbon connector for the sensor cable, for the sensor board, okay, sure. 1 or 2 times solid state relay, AC or DC switching nearby. Okay. Good. Yeah, I wish, Greg. Okay, so we're going to take a look at that. We want some solid state relays. Let's see if LCSC has solid state relays. I don't know. I think so. And then maybe we can also import a footprint with that and stuff like that. So this is done. Solid state. Sure, maybe we can do this open sourced. SSRs. I don't need this. Now, I've never used a solid state relay like this before, so I have no idea what I'm looking for. Generally, I sort by availability and stuff like that. What does this do? An error occurred. Great. This thing? More errors. What do you mean? So I wanted to use some of those plug-in relays, right? Let's see if we wanted to... Oh, okay. That's not going to work. No. DC. I want it to be AC and DC compatible. Yeah, so what I want is basically the top module there. This thing here. Yeah, this would normally go on GitHub. What? It's 27 bucks? Okay. Yeah, no. So maybe we should look at something else. Lots of values. Okay. Okay, let's see. Let's say we wanted to do up to 5 amps. Oh, there we go. That's kind of what I was looking for, but this is 12 bucks. It's kind of like what I want. Like, I want a module where we just put it in the board and we control the pins. But not for 12 bucks. That's not going to happen. So let's say we want, what kind of load current? Okay, let's see what kind of results we get here. Is this really? Is this also a solid state relay? No, it's a photo relay. Okay, that's not what we want. So we need to change something. Normally open. No, sure. No, still not it. Sure, probably, but I just don't know what I'm looking for, so I'm just trying to find the settings I want. So we don't want SMD. Let's take these away and figure out the package we want. Because I don't want a little through hole, something through hole. There we go. We can use this chonker here. No, we don't want that. We might be in the wrong section. I don't know. So let's search by, wow, this one's 13,000. What? We want in stock stuff, please. Jesus. I'm just gonna go reverse logic. So what's this? So this can be controlled with 4 to 15 volt DC, and then it can do 5 amps 480 volt AC. That's good, except it's way expensive, but this is a SIP4. Okay. So let's look at SIP packages. And, okay, sure. And now let's find the cheapest. Okay, here we go. So, what's this? Yeah, this is more in line of what I was looking for. This can do 280 volt AC. They're, if you buy 1,000, they're $1 a piece. That's okay. And we have load and input. Oh, these can only do 2 amp. So let's see, this one. 2 amp. Okay, this can do 250. Wow, these things quickly get expensive. $12 volt DC. But that is the kind of package, or somewhat, that I was looking for. Let's see if there's other... Hold on a second. Let me... where... This one? Yeah. So what I'm actually looking for is, like, on AliExpress you have boards like this. Let's see, let's just open it. And they have these solid state relays on there. And I'm looking for just the black, go away, the black part here, right? And so like this guy. I guess $2 a piece isn't a weird price, huh? Okay, so like this one. One channel is $268, and then they're still shipping. Okay. 2 channels, yeah. But of course, we only need that single. No, buy those and desolder. That is not a good business plan. Maybe we can read the name off of this one. That's an Omron. Probably a clone, but still. Let's see. Can we find Omron on LC? Yeah, okay. We have LCSC Omron. And then the cable assemblies, fiber optic, integrated circuit motor, storage. Jesus. Solid state relays. Okay. So now we're only searching the Omron brand. Okay. Rated voltage. Let's see what it does. There's one. What do you mean? AC. No, yeah, okay. It's harder to search for these than I thought. A Omron G3MB. Okay, so LCSC has them, but they're hella expensive. And they're not in stock. Okay. So let's see a different brand someone here on AliExpress might be using already. Philip will desolder it. I don't know about that. No, LCSC doesn't stock everything, so I can get parts from lots more suppliers. It's just an easy way to find parts. So maybe it's just... Oh, we can try ENMG, see if they have that brand. Nope. Okay. But it's just a question of finding the right part, and then, you know. Because these also say G3MB, but then the Omron logo is gone. What? No, it's no secret, but those generally are Chinese shops which you have to go through a middleman and stuff like that. Right, so finding solid state relay, not as easy as it seems. Let's see it. I want 10 pieces. And this one can do 2 amp, 240 volt AC with 5 volt input. Yeah, we had one of those, I think. Yeah, right, so these are kind of where it's at. So Solu, let's go look at them. They only make SSRs. Okay. So these are way too big. So this is good. So we have one that does load input, but then what is the input? So let's take a look at the data sheet. Okay, let's download it. There, thank you. Okay, so we have a nice Chinese data sheet. They have a 5 volt, 12 volt, and 24 volt version. And we can switch it between 4 and 6 volt. That's great, because then we can use a load switch or something like that. That is easy. Let's see, what is this? Translate input voltage range. Ensure the voltage is on. Okay, so it needs at least 4 volt, sure. And then the load, is this the load? Output voltage range. Okay, 280 volt, that's fine. Okay, and we can connect it. Yeah, we basically just connect this. Let's see what this all means. Relay soldering, heat generator, relay internal circuit lacks reverse polarity protection. When wiring, ensure correct input and output wires. Okay. Okay. Oh, here's the naming. Okay, so the KS4, and then we want a 5, and the 2-4, I guess. And what does this mean? 0 crossing type. Random. Okay. 2 amp. Lead pin. Okay, yeah, okay. And here we have the pinout. So we have various versions. Choose the Z. Okay, yeah, okay. Okay. Temperature derating. Can't buy DIY? What do you mean? You can buy from LCSC. So this is the KS424. We have the 12 and the 5. We want the 5 because switching it with 5 volt is easy because we have 5 volt on the board. Okay, yeah. Well, these are still, you know, $1.50 a piece. And they're out of stock. But I think it's a good one to start with. And we can always switch later. So what we can do... Make your own SSR. Well, I'm not going to mess with AC. I'd rather not even do anything AC on the board. But I can imagine someone wanting to have a switching capability on that board, right? So kind of the same as they did on this one. With the relays. But the relays are way too big, but they're probably cheaper. But we don't have that much space on the board because we also need to fit a PUE circuit on there and all kinds of other stuff. So I'd rather not have these relays, and I'd probably also want to use smaller connectors. No, I'm not too worried about it because I could just source it through someone else. I just need something to design with at first, and then I can do final part selection later. I just need to know, you know, kind of what is out there and what the values are and the sizes and blah, blah, blah. But if I go to my supplier and say, hey, I kind of want this, can you find me a clone or copy and then get me their data sheets and then maybe a few samples and then we can test them and yeah. So anyway, yeah, we can copy this kind of stuff. I don't know. We'll see. Oh, you're messing. Okay. Right, so I'm going to show you a little trick. Oh god, that's not going to work. Okay, we need to go to the main KiCad thingy, and we want a plugin, which of course you're not going to be able to see. Oh, you are. Okay, good. And I want a few plugins. I want KiBuzzard for some nice silkscreen stuff. Interactive bomb is always good. JLC is easy to have. But there's import GUI. This is the one we want. Okay, whatever. Apply. Oh, okay. You can't see the apply window, but it's installing everything. Okay. Close, close. I'm going to go to the PCB now. Need to make a new capture window probably. Yeah, hold on. First resize it. Okay, and now we need window capture, KiCad, PCB view. Okay, it's too big. There. Again, we don't need this because I want to use import GUI from here. You don't see that. Jesus Christ. Okay, I'm just going to capture my display. Okay, the import GUI is here, and what it can do, it can check if LCSC has already a footprint and a schematic symbol, and we can import those. Now, I don't want to set this up right now. Yeah, I guess we should. Okay, desktop. We'll name it KiCad import. No, okay, okay, whatever. Okay, and now I'm just going to hit import. It's going to give me a whole kind of crap. But it's found a symbol let's see, yeah, and it found a footprint and some 3D models. That's also good, so we can use those later. Now we don't need the PCB editor anymore, so I'm going to close that. I'm going to minimize this and go back to my schematics editor. And now I'm going to go to my symbol libraries. Yeah. And we just imported it into some kind of import library, so I'm going to call it KiCad import. Desktop, wall, sensor panel, KiCad import. And here we have 3D shapes and pretty. We're going to select the pretty directory. Why is it saying, what does this mean? Unknown library type. Okay. Really? KiCad? Okay. So now we imported a library symbol in theory. We're going to create a new object. Oh god. Okay, let's close this one. In theory, we now have a KiCad import over here. But it doesn't have any footprints or symbols. Did it not import the symbol? Ah, okay, this is just 4 pins. Okay, so 1, 2, 3, and 4, but what does each pin do? Does it say on here? Okay, 1 and 2 are the load, 3 and 4 are the signal. Oh wait, sorry, you're still in display capture. Yeah, 1 and 2 are the load, 3 and 4 are the signal. So we can just use a generic footprint. So we're going to say 1 times 04. Connection pins or socket or whatever, screw terminal. We can just use this. Okay, sure. Can I mirror this? There, like that better. 1 and 4, so I'm just going to add text labels. Load AC. It doesn't really say 1. Sure. Switch. DC 5 volt positive. And this is switch DC 5 volt negative. Okay. So yeah, if we then later link this, because if you want to put stuff on the PCB, you're going to have to link it to like a footprint that is actually going on the PCB. I'll show you that in a minute. We can link these together. So I'll demonstrate that real quick, and that's going to be also near the end of the stream. So let's add a terminal. Screw terminal 1 times 2, because we have 2 pins. Okay, that sucks. I'm just gonna turn this around. There. So this is going to have a terminal to outside of the board, right? So that's the terminal you connect your AC whatever to your load, your light, your lamp, or whatever you want to control with that. And this is our switch. So I think this can just be ground. And then we need a 5-volt signal. Now all signals from an ESP are always 3.3 volts, so we need a circuit to actually get a 5-volt signal. So I'm not going to do that right now, but in the end, what we'll probably do is we'll have our GPIO4 here, for instance, which will be the plus. We're going to use a load switch. I'll show you all of that later. But that would then either be low, switch would be off, or high, switch would be on. And we can see that in the PDF, in the schematic, in the data sheet. Basically, they're saying you're going to have a plus and a minus, and that needs to be a circuit. And if that's a circuit, so current can flow, this will turn on. And if it's not, it will turn off, right? So if both are ground, well, we don't have a plus and minus, so it's 0. And they said above here, the minimum current for switching, translate, ensure the voltage is on for the 5-volt model, which is the one we selected, is 4-volt DC. So we need to switch 5-volt either to 0 or to 5-volt, and then the solid-state relay will turn on or off. But we're gonna look at that in a different episode, because adding a load switch is complicated. So now we're just pretending to use GPIO4, which is of course wrong, but okay. I need to edit this, because we're going to add the LCSC component that we just selected there. So that is this guy. Just to keep track so I can find it again, right? So we added that to this connector pin here. So if we now want to put this on the board, let's go there. We're not done with the schematic for at least another 5 or 10 episodes. So, but I know you kind of want to see how you can progress. There's a little button up here that is the assign footprint button. And that is a pop-up you cannot see. Okay, window capture, KiCad, assign footprint. Not sure this is the best way to do it, but this is how we're doing it now. Okay, and you have these J1, J2, J3, and J4. And if you see down below there, you can see that if I click it, it goes to a different symbol in the schematic. So we need to assign basically a physical footprint, how that will look on the PCB, because, well, the schematic is the virtual version, and then the footprint is the physical manifestation of that, I guess. So these connectors, we already selected the 2mm through hole. Oh, you have AC power, nice. So we're going to go to pin headers, 2mm. Maybe I can make this a bit bigger for you guys. And it goes over the chat. Okay. And we need to select the right one. So pin headers 2mm, and it is 2 times 7. So 2 times 7. We can get a little 3D preview, or a 2D. You can't see the preview either. KiCad footprint preview. Nope. Okay. Hey there, Pepsi. And this kind of looks correct. We have a pin header that is 2 times 7 with 2 rows of 7. That looks good. So we're going to assign that to this one and this one. And then we have the CON4 pin. But we know that it's not really a connector. That is our solid-state relay we just selected. How did I call that again? Wall panel something. Okay, I need to see if those libraries are here. Oh, okay, now we need to create the library. KiCad import. I don't know, whatever. Uh-oh. An unhandled exception. Retry. Okay. It's dead. Let's open it again. KiCad found unsaved blah blah blah. Sure, restore. Keep all files. I don't know. Oh god. It's now not capturing stuff. Hold on. Loading footprints. Why is it not showing anything anymore? Do I need to do... Oh god, I need to do everything again. Okay. Okay, it did save this stuff. Sorry, it's not showing the schematics for some reason. There. Okay. Okay, all our schematics are still here. That's good. So let's go to assign footprints again. Maybe I need to assign footprint. I need to link these differently. Yeah, okay. Hold on. Thanks. So we're going to do the same thing again. Pin headers, 2 millimeters. 2 times 7 vertical. I'm going to hit apply and save. We're going to go to this connector, and now we should be able to find our import library, KiCad import. And this is the one... nope, still not working. Preview. Why not? Okay, this is the one we imported from LCSC, so we can see that. And this just has the pin 1, 2, 3, and 4 from the schematic, but then laid out in a physical footprint, right? So we're going to select that. And then we need a terminal. We're just going to use a, I don't know. How are they called again? Oh, we can use Dexton. Okay. What kind of terminal block is this? We need a 2-pin. That. Oh, I don't like those. Okay. Phoenix. Sure. Okay. Save. Equivalent of smoke. Yes. And now we can go to the PCB editor, which of course doesn't work. Why not? I need to lower this one. Sure. And in the PCB editor, we have a button called Update PCB from Schematics. It's over here. This, brown green one. Update PCB. And then we get our components. So this is our relay. These are the 2 connectors that are coming from, this board. So this guy, right? And there's all these lines here. So what you need to do is, in the end, we need to structure this somehow that, it makes sense where all of this is. And then we can connect lines like that. Then again, you need to pay attention to that, because those lines can carry up to 2 amps, because this is a 2 amp solid state relay. So we can draw a line like that. Whatever. But that can't be 0.2 millimeter. This needs to be like 1 millimeter or something like that. And same for this guy. Oh. Okay, that's 2 millimeter there. Anyway, that's something we're going to do very much later. We still, we need to work on the schematics for weeks on end. That's kind of how it works. But I just wanted to show you how this looks physically. Like, okay, this seems to be connected to both. Oh, that's ground, okay. And this is connected to GPIO4. But yeah, in the end, this will become a whole PCB, which has to be laid out logically on a PCB that's going to fit, and things aren't going to go the way we think they are. Yeah, it also has a 3D view. Yeah. I can show you. So this is also ground. Whatever. This is just stupid mock-up. In the end, this isn't going to make sense. But yeah. We can take a look at 3D view, sure. I need to add that. I need to think about a better way of doing this. KiCad 3D view. Select the window. 3D viewer. There. So this is the 3D view. So these are the pin headers we selected. Those are pretty generic. This is the terminal we selected. You can already see this doesn't make sense because the openings are the wrong way. And then this is the imported solid state relay, which doesn't have a 3D model. So we can go in here. Hold on. And we can edit it. We can go 3D models, and it says, oh, I tried to get it from here, but that's of course not where it is. Oh, it is here. Yeah, that is right. No, it's not here. 3D shapes. There. It's not, oh, you can't see. Okay, I need to figure out a better way to do this. KiCad edit 3D. There, sorry. So you can see this is misaligned because we kind of imported it from LCSC. So we can just align it like that. No, not right yet. No, also not right. 6. Maybe 7. 6. That's better. This looks good. Okay, so if we now go to the 3D view, we have our solid state relay in there, our screw terminal, and the 2 pin headers we made earlier. Of course, this has nothing to do with the PCB we're going to design in the end. I just wanted to show you because this is kind of a visual representation of the schematic we just made. Oh, it's Dr. Z's. We can do some ray tracing. Whoa. Of course, our screw terminal's the wrong way around. How are you doing, Doctor? But now this is, we're going to have so much fun doing this. Okay, whatever. Anyway, yeah, that's just, I wanted to show some physical representation of kind of what we just made. But as I said, we're going to spend weeks, many weeks in the schematics editor. And then later we're going to spend many weeks in the PCB editor. I'm not going to save this. Nope. Yeah, so that's kind of to give you an idea how you build this up. First, we work on the schematics, and during the schematics, we also do component selection, and then we work on the PCB, but the component selection can actually change while we're working on the PCB if we can't fit stuff, or it needs to be bigger or smaller, or, Sure, I can make a playlist of it. 2 hours of work, almost nothing to show for. We mapped out the connectors. Philip definitely desoldering now. I'm mostly selecting from LCSC. So, for instance, we had a solid state relay we selected, and yeah. Of course, these are out of stock and like $2 a piece. So it doesn't mean that's going to be the real component in the end, but you have to design with something. And then maybe if I get a different one or a clone or replacement, you know. Or maybe it's just we decide it's too expensive and leave the feature off, or don't solder it and people can solder it themselves. I don't know. We'll figure that out later. Can we design a smoke generator? Well, the problem is once we make the first prototype, we're going to do it all live on stream. So maybe we'll get smoke. Maybe we missed something on the schematic, or maybe we did something in reverse or built a stupid circuit. I don't know. So yeah, how long have we been going? 1 hour and 50 minutes. I think that's a nice time to call it, really. Yeah, I'll try and make a playlist of this so people can follow along when they're starting later. I hope this will stay fun and entertaining, because this is going to take tens of streams. If I want to do everything on stream, I don't think I'm going to do that. So like the PoE circuit, I might design off stream and then we'll discuss it on stream, things like that. But I'll try and do most of it on stream. But hours of research, yeah, that's going to be boring, I think. You know, secret time. There's no secret today. Is there? No, I don't have a secret yet. I did order something this week. I can actually show you. Okay. Let me. I'm gonna instead of showing you a physical secret, I'm gonna show you a virtual secret. So let me open that real quick. Hold on. Where is it? Okay. One moment. Where is it? The Octa. Let's see if it opens it in the right. Oh, it does. Okay. Don't share nudes. No, don't worry. I'll share the 3D viewer. I don't know if I want to share the PCB yet. Oh, this takes a while to open. It's still opening. Okay. Oh, I got most of the models. That's good. Hold on. Okay. No. There. Okay. So this is a 3D view of a board I've been working on. This is a Dig Octa System Brainboard P48L. What? And so this is a work on a new brainboard, which has a, let me find it there, an ESP32P4 on there. So that is a much higher power. Oh, later, Dr. Z's. Much higher power ESP, well, 32 which I want to make a brainboard for in the Dig Octa system. And this is my first attempt of doing so. So basically this is after weeks of schematics and board layout and stuff like that, which we just looked at. But then in its final form, or at least I ordered the first prototype 2 days ago, so it's going to take 2 weeks or so for them to build and arrive. But yeah, so in the end, we're going to end up with something that, vaguely looks something like this. I hope it's going to be less complex. Yeah, this is going to have more channels and better frame rates. So this can easily drive 16 channels at like 600 LEDs a piece. So shouldn't have a problem with that. Problem is, there's currently no hardware, but also no software. So I'm making the hardware, and I'm hoping the software catches up. Right? Why didn't we start with this? This is not a board you start with. This is a very complicated board with multiple buck converters on there and all kinds of level driving circuits and multiple processors, ports, lots of stuff. Yeah, I'm sure. This is 6 layers. Oh, you can actually... Okay, I do have the PCB on screen, it seems. You can see that this gets complicated quite quickly, because this is layer 1. Then we have a ground layer. Then we have a power layer. Then we have more signals. Then we have even more signals. And then we have another ground layer. Had to botch this. Still hate it, but okay. Okay, so let's click that away. Yeah, eventually the software will come. I'm not too worried about that. We forgot to drink the Sprite Zero Sugar. Where's my KiCad? There. The Sprite Zero Sugar Mint. I'm going to drink it now while we talk about it. No? Okay, whatever. The wall board. So the backboard for this guy, it'll probably just be 4 layers. Think we can manage it on 4 layers. But that P4 board is mucho complex. So, yeah. The backboard we're going to build for... it's not this guy. This guy. That's going to be a lot less complex. Because basically the complexity of what you just saw is already on here. And we're just going to hook onto that. You have a box of strips that want to run all at the same time. Yeah, and it'll slot into the Dig Octa system. So you can use all of the 4 available power boards. Which, don't have to... They can stay the same. And that's always been the idea of the Dig Octa system, where we can have multiple brain boards, and you can take the one that matches best with the specifications you need. Yeah, Foxionaire, we're going to use a 4-layer board at least. I don't think we need to go to 6 layers. And then we'll work with multiple layers and ground planes and power planes and all that kind of stuff. 2 questions. I have a 600 watt supply and my run of strip is 640 watt for about 15 to 16 meters of dig cob. 640 watt? 15, 16 meters? That doesn't make sense. That doesn't compute. Let's take a look real quick. Window capture, no. Browser Edge, okay. Let's open a browser. So, wait, hold on. Queen LED. Let me share a browser here. No, that's the chat. It's not detecting the browser. Why not? browser, Chrome, this one. Yes. Thank you. Good. If we go to digitally addressable, and then we go to the LED usage power sheets, and then we take the 24 volt sheet, and then we zoom in on the Quinn LED strip, we see that a 100% RGB white uses 166 watts, but 50% RGB white, which is generally what we calculate with, uses 96 watts. So let's say that uses 100 watts per 5 meters. If we do that times 3, that is 300 watts. Okay, so that's your 15 meters. And if we look at, for instance, the 100% rainbow effect down here, we see that only uses 70 watts. So calculating with 100 gives us a bit of margin. We can do 100% dedicated white. Can we? Wait, this one, dedicated white, is 70 watts. And just like rainbow is also 70 watts. So calculating with 100 watts per 5 meters gives us plenty margin. And so you'll need 300 watts for 15 meters, not 640. I think that's a realistic number to calculate with. No, the 204 watt is if you do 100% red, 100% green, 100% blue, 100% white, all at the same time on all of the LEDs together. That is a very unrealistic scenario, and I wouldn't advise that because it also gets very hot. Normally, you might be running 100% white. That is 70 watts. Or you'll be running 100% rainbow. That is also 70 watts. And maybe you'll do a little bit of color red and another color, and then you're running at around 100 watts. So I'd say calculate with 100 watts. So 100 watts per 5 meter, that should be fine. Did you not watch my... Oh, okay. There is a... blah, blah, blah. The Ultimate LED Strip Power Injection Guide. It takes about an hour, but it'll help you form a document and do all the calculations and wire sizing and how many injection points you need, what kind of wire size you need for that injection point, blah, blah, blah. All of that stuff it'll do, and it has nice schematics in there. And at the end of that video, you will be able to calculate your own setup. Right? Like, for instance, if we go to the Dig Next 2, and we go to, oh god, there's so many articles, the wiring guide, and we go to the high power section, there is actually a DigCobb 160 example in here. If you want to use 10 meters, or if you want to use 20 meters, you can still use a Dig Next 2. And it shows you how to wire it, etc., etc. No, don't design for the worst case scenario you'll never use. Design for what you'll use and a little bit above it, and that's the 100 watt figure. The Dig Next wiring guide, sure. You'll still need to calculate the cable diameter and stuff like that, but the other video will help with that. No problem, Greg. No problem. Lots of diagrams for the dig next. So if you want to do something with a controller, it explains everything how you need to do it. Okay. So yeah, that was an interesting stream. You know, we're gonna work on more of the schematics next time. Or maybe I'll have a video or do something else, but I do want to continue this as a series and mostly do this together. As I said, some stuff I also need to figure out for myself, like the PUE circuit and things like that. But, yeah. Well, there is a button, but yeah. Greg, sure. But there is no one-size-fits-all, so just calculate what you need. Using something thicker than that is fine, but yeah, you need to calculate. Oh, CJ was here too. I didn't even see him. That's true. That's true. Buying stuff is also fine. I also get a bit of money from that, so that's fine. Okay. Tune in late. Yeah, we did some PCB design stuff, but we're gonna continue another time. So. Okay. Yeah, I'm gonna round off the stream. Thanks all for hanging around, and I hope to see you back next time when we're gonna do more design stuff. It'll be a bit hectic, but in the end we'll have a beautiful schematic, and we'll have, well, we probably won't have a beautiful schematic. We'll have a schematic, and then we'll make a beautiful board, and then we're going to do prototypes, and then we're going to see how stupid decisions we made, and stuff goes up in smoke. Then we're going to redo the schematics, and redo the board, and try it again, and at some point, in a year or two's of time, we'll have a very beautiful board. So, yeah. Thanks for watching, guys, and catch you guys the next time. Bye-bye.
Remember all the happy times we had. Very much alike. All right. I'll tell you the truth.